Why are there two forms of Maxwell's equations? These ones are called the differential form, and these ones are called the integral form. But these are supposed to be the same equations, so how does one go back and forth between the integral form and the differential form? For the first two laws, namely Gauss's law for the electric field and Gauss's law for the magnetic field, we are going to use a key result in vector calculus. This result is known as the divergence theorem. This theorem basically says that if I have a box and I take every individual point inside of the box and I think about how much electric field is it emanating, is it a source of electric field or is it a sink of electric field? That's the left-hand side of the equation. Well, if I add those all up, that's the integral, then what I should get is how much of that electric field is penetrating the surface, whether going outside or going inside. That's called the flux. So we can use the divergence theorem to switch between a divergence into a flux integral. Now for Ampere's law and for Faraday's law, we are going to use the other key result in vector calculus, namely Stokes' theorem. Now geometrically, Stokes' theorem is basically saying that all the little swirlies that are inside of this closed figure add up to be the large swirly on the circumference of this figure. So basically, if I take a closed loop and I go around and do a line integral, that is equivalent to adding up all the curls that are inside of the surface. And just like that, by using the divergence theorem and Stokes' theorem, we can go back and forth between the differential form of Maxwell's equations and the integral form of Maxwell's equations.